In this lesson, we continue to learn about the basics of descriptive statistics, including tabulating and displaying data. Descriptive statistics involves the collection, presentation, and analysis of data to provide a summary of its characteristics. Its purpose is to summarize and describe the features of a dataset through numerical and graphical measures. Now that we have an understanding of the levels of measurement from Lesson 1, we can look at how one can display and graph the data for a better understanding of the population, as well as getting an answer to any research questions about the data. Often, just looking at the raw data can be overwhelming with all the numbers. To start to make sense of the numbers, we are first going to look at a frequency distribution of the data. This is a way to look at the frequency of the measurements, or the counts, and how much they occur in the data set. You can do this manually by just putting the data in order and counting it to figure out how much each value occurs. As you can see, that's kind of arduous, so we're going to have the computer do this for us. In the distribution, we are going to see 4 main items. That will be all the values, the absolute frequencies or the counts that we have for each one, the relative frequencies, and that's the percentages of each data point that we see in the set, and the cumulative relative frequency. That's the percentage for a given score combined with all of the percentages before it. Let's look at an example. So, here we have a data set where we see values of 1 through 5. This could be a pain rating or similar data. Here we see the frequency of each value, so 10 times we saw the recorded value of 1, 20 times we saw the value or rating of 2, etc. 40 times we saw the value of 3, so we're seeing a lot of 3s in this data set. This could be a pain rating where lots of people are reporting the middle value of 3, right? So, doing the math, 40% of the time we see a level of 3. This frequency distribution can also be done easily with our computer software measured at any level. For nominal level data, the cumulative frequency doesn't really make sense because they're just categories, right? It's not like we're looking at an interval or ratio measurement like cholesterol going from low to high in numerical value. If it's just a category, the cumulative frequency is not going to have much meaning for us. So, when we do a frequency distribution for a nominal level variable, we leave out cumulative frequencies from the table. Here's another example of a frequency distribution, this time for weight. If we see a typical weight distribution, you might see that there's a lot of values to count and categorize. When there is a whole bunch of numbers, we can group those and do what's called a group frequency distribution. When there's a lot of numbers and it's over a wide range of values, then you can start to group them by 5s or 10s, and then you can see from there it just doesn't give you that huge long data table. So it's a little easier to handle the data this way. It's appropriate to group these distributions only when you have a large range of data. When we report frequency information in a paper or presentation, we have several options on how to communicate our results. We can state the counts and percentages in words, or list our frequency distribution table, or we can graph our frequency distribution. Since humans are visual creatures by nature, graphs are a preferred way to share frequency and other statistical results about a set of data. One way to display frequency information is in something called a bar graph. We also can display counts of data in a histogram or a pie chart. Bar plots and histograms are often confused. However, bar graphs are the ones we use when we're displaying nominal level data. If we look at an example of a bar graph that depicts some nominal level data like marriage status, we know that this level of measurement is a category. So, bar graphs have separated bars. They have the gap in between each category as you're either measured as one or the other as married, single, divorced, or widowed, right? You can't be married and single at the same time. And you can't be married and divorced at the same time, so these are categories, right? Again, with a bar graph, the bars don't touch each other because they're separate categories. Let's do an example using our StatCrunch software. We can start by loading in the hypertension study data that needs to be analyzed for this module's assignment. Once we have the StatCrunch software open, we can easily do that from the Data tab and load in the data from the Excel file for the assignment. We could also type in the data into StatCrunch, or copy and paste it from Excel, but it is easier to just load in the file. To do that in StatCrunch, we simply click on the Data tab, click Load, then from File, then, on my computer. I'll drop and drag in the file. So, once we load the data in, you'll see that there's several categories of variables that we have here. We have the age, sex, ethnicity, etc. of the 50 subjects in the study. And you see the categorical or nominal level variable, sex or self-reported gender expression that has just 2 categories here. Again, this is nominal level data, categorical data that we can easily graph in StatCrunch by just simply going to the Graph tab here. And instead of a histogram, we're going to click on bar plot with data, since we have the individual data of all the subjects. So, we pick our column, sex in this case, in constructing our bar graph. We can give the graph some labels depending on the type we selected. Along the x-axis is going to be our category. So, this will be sex or expressed gender. Our y-axis label, we can call frequency or counts. We can even give the graph a title. Study makeup, in this case. Then we just click Compute and StatCrunch will create the graph. So, notice we have, unlike with a histogram, we have spaces in between our bars as it's really not contiguous. Right? We can't be both reported sexes at the same time. You're either one or the other. So, you're falling into these categories or separated bars, and thus we have a bar plot. Let's do another example using summary data. If we want to look at the mean childbearing age by country, in the 5 countries in this module's discussion question, examining population growth data from the United Nations, we can easily create this graph in StatCrunch. Again, we start by loading the data into StatCrunch. Here we can just copy and paste the data in and create our plot. Start with a new datasheet in StatCrunch, and then copy and paste the United Nations 1970 data in from the Excel sheet in the discussion area. You can paste right onto the gray variable area, and all the variable labels should transfer onto the StatCrunch data table. Now we have all the data in the datasheet including the country, fertility rate, mean age at childbearing time, etc. Again, if we analyze by country, this is nominal level data, categorical data that we can graph in StatCrunch by just simply going to the Graph tab. And we're going to click on bar plot, and with summary, since we have a total of the data, and not by individual subjects. So, we pick our category here as country in this case, and display counts in the mean age at childbearing in constructing our bar graph. We can give the graph some labels here. Along the x-axis is going to be our category, which is country. Our y-axis label, we can call our variable mean age at childbearing. We can even give the graph a title. Then we just click Compute and StatCrunch will create the graph. So, again, notice we have spaces in between our bars as it's really not contiguous. Right? We can't be in both countries at the same time. You're in either one or the other. So, you're falling into categories by country with separated bars, and thus we have another example of a bar plot. This one shows us that Chinese women have the oldest mean age at childbirth, likely a sign that they are delaying having children under the one-child policy. Pie charts are another type of graphical representation to display nominal or categorical data in a circular shape, which is divided into slices or segments representing the proportion of each category within the dataset. The size of each segment is proportional to the percentage or frequency of the data within that category. Pie charts allow for quick and easy interpretation of data by providing a visual representation that is easy to understand, especially when comparing data sets with few categories. However, they can become difficult to read when there are many categories or the data has a small variance, making it difficult to discern the differences in segment size. If that is the case, a bar plot may be clearer to read. A pie chart is also easily done in StatCrunch just by clicking on the Graph tab. We can make a pie chart out of the hypertension study data we just did on the gender of the study subjects. With the data loaded into StatCrunch, now we pick pie chart with data. Then we click on our variable, sex. Here we can put in counts, or probably the best thing to do is % of total to display. We can even go ahead and give our pie chart a name. And click Compute, and automatically we have a pie chart done in StatCrunch. We can then copy and paste our chart into our Word document or any other document we are working with. Tabulating and displaying data is a powerful tool for statisticians. It allows one to convey important aspects of the data for presenting to colleagues or patients. In the next lesson, we will learn the more complex data displays for continuous numerical data that belongs in a histogram.